What's up everyone, welcome to Developexx. Today I'm going to show you how to create a logistic regression using R. So first we are going to see the code and after I will run it. So this is a practical example. I really used this code in order to make some research on chess. So first what you have to do is to install and load the following packages. So this is why the code is starting like this. Read Excel is useful if your data are from an Excel file, and actually this one is not really useful in our case because it will be for another video. It will be for useful for this part of the code, which is basically a graph representation of our result in order to interpret them better. So I'm not going to explain you what is a logistic regression. I assume you already know and you just want to know how to do it on R. So just a bit of context in order for you to understand how does it work on R. So these are the data I'm working with. I want to have an idea of the impact of the rating difference, so the elo difference between two chess players on the outcome of the game. So these are the only two columns that will be useful in our case. W is for white won, B is for black won, and D is for draw, so nobody won. W is a victory because our point of view, the rating difference is according to white. So this is a win, this is a lose, and this is a draw. So now you know how our file is composed. Let's see our code. So first you have to name the path. So in order to have the path, you just click, you do a right click on your file, and after you do copy as path, and you basically just have to paste it after, and you have the path between guillemets. So this is what I have here. I named it Fichier Excel because I'm French, but you can name it as you want, it doesn't matter. Then you name the sheet also. So here it's group 7. And then this is why Read Excel is useful. You will write this. So you will name this name hasn't any importance, is not important at all. But what is important is this read underscore Excel, which is a function of Read Excel. And then you will first include the name of your file, and after sheet equal the name of your sheet. So if you want, for instance, to put A here, you have to modify also and to put A here, you know. So after we had the data, just to be sure that we imported the correct data and we are not wrong. And so here I will convert my W, B, and D into a Boolean variable. So a variable that will take only the value 0 or 1. And I want this variable to take the value 1 if it's victory, so if white won. And I want this variable to take the value 0 otherwise, so if it's a draw or if it's victory for blacks. So what we will do is that we will select données train, which are basically are this, basically. So the Excel file and this particular sheet. I will name the variable that I want, so it's result binary, but you can write anything you want again. You just have to modify it in the whole code after. If else, so if else is a function that will, under a certain condition, take a certain value and otherwise another value. So if in données train, so in this, and in the column results, so this is the column results. So if result exactly equals W between guillemets because it's a letter, Then let results binary take the value 1, and otherwise, so if it's black or draw, let's take the value 0. So now our data train updates are updated, and we have another column in R, which is result binary. So once we have our Boolean variable, what we will do is that we will select only the column in which we're interested in. So this is this part of the code. So here you can see that this is why we loaded this library. So yes, we want to import first result binary because this is the outcome of the game in terms of 0 or 1. And also we want to import rating difference because we want to see the impact of the rating difference on the result binary. Then we had our data again, just to be sure that we have only the two columns. And yes, just these are just basically some verification, some checks, that everything is working correctly. Now we're going to create the logistic regression. So again, this is a variable. You can put whatever you want as a name. And this is basically the code for a logistic regression. So here you have your y and here you have your x. So we want to measure the impact of this over this, and you have to separate them with this special character. So if you have more than one x, for instance, let's say that I have also a variable called I have to add a plus in order to add this because if I add a comma, R will not understand basically because the comma is a delimitation in this function for something else. So you have to put a plus if you want to add more x. So a little tilde between the y and the x and a plus between the different x. So let me just remove this because I will get an error, of course, because there are no variable in my file called a. Then this is just a line to summarize the logistic model, so the results. So here, let's make predictions. This is the last part of the code. This is different if you use logistic regression in order to make predictions, or if you use logistic regression in order to quantify an impact of a variable over another, like I'm doing. Because here, in my case, I should try the model, I should make some predictions over the same data because I want the impact on this data. But if you are working in finance and you want a model that will predict the value of an asset, or I don't know, you have to try your model over over some new data, because as your model have been trained on certain data, of course, it will adapt to it. But if the correlations between two assets, for instance, just are different over the time, the model will be okay for your data, but not for new data or data of the past. I don't know. But this is not a finance course, and I don't know how to explain it. I hope it was understandable. So here, basically, you have, so this is the name of the variable, then you predict, you use your model, so this model that you obtained just before, and then you use same data, so new data equals this. And so here you have two ways to categorize the results that you obtained. So if else, again, the same thing that we had here. So if else, the prediction made by our model are over 0.5, it means that the model predicted a victory, so 1. Otherwise, it predicted a loss, so or a draw. so 0. But what you can also do, and this is why I've put in this here, is that you can just basically say that between 0.3 and 0.7, the model predicted nothing. I mean, you can say that it's not representative because the model is not clear enough, and then you just write this. So this is an alternative code if you want, just to uh, take into account only the extreme value, if I can say it like this. So this is not what I want to do. And yes, here it's okay. And after, to finish with, we have the confusion matrix, and we will see right now what's happening. So let me just put this like this, and we run it. So it doesn't take so much time because I just have 90,000 observations, and the results are just here. Okay, so now let's analyze our results. So here the packages are basically loaded. Here I obtained this because I had some bullshit here. I mean, something, I don't remember what I had. I had this, you see. Because it was some means and some standard deviation that I forgot to remove. But anyway, it doesn't have any importance because we will not select this column. So yes. But the thing is that automatically R will give some names to these columns in order to take them into account. So except this, we can see that here we have the exact same thing than here, so it's perfect. And you can see that after the selection, we have only the two variables that we want to analyze, so it's perfect. And after, we have the result of our logistic regression. So here the intercept, here the rating, the coefficient for the rating difference, which is here. This is the intercept. These are the standard error, the z value, and this is basically the p-value here and here, which is extremely significant in our data because the closest it is to 0, sorry, the better it is. So yes, this is our result. And this is our little predictions. So here, as you can see, make predictions. So the confusion matrix, we can see that here it's the predictions, here the reference, so the actual results. So how to read this? It's basically that for 30,800 observations, the model predicted a loss, and what happened was a loss. And actually, here, the model predicted a loss, but actually it was a win. So, the model was wrong, but this and this are the correct predictions, and this are the wrong predictions. So this is the accuracy. It means that if you take this plus this, so the cases where the model were right, over the total amount of data, we have 0.64. It means that in 65% of our cases, the model is right. Here is the confidence interval, which is really close to the accuracy. So this is the confidence interval, sorry, for the accuracy, of course. It is really close because we have a lot of observations. So yes, our sample is pretty big. These are important, but not that much. In the total of false positive, false negative, and yes. We're going to see this maybe in another video. Don't hesitate to ask me if you want me to do another video like this to analyze these particular variables, these particular results. So I think I'm going to put in the description of the video the code. And yes, I'm telling you bye bye, and let's see each other's in another video. Don't forget to subscribe to Developexx. Bye bye, guys.